Oh shit. It's tutorial time! Hello. Hopefully you guys can all see and hear me. So today we are going to be in for a challenging session. It's very rarely been attempted to program chess within like an hour, but we're going to try today, and by the end of it, I'm sure we will all have a very firm grasp on object-oriented programming and all of these ideas. So very importantly, first and foremost, you guys will need the doc. So let me just get you that right away. So in here, I've got this Google Doc. I'm gonna send you the link once again. You all want to have this open because there's a lot of words here that we're going to be using. There's going to be a lot of, keywords, a lot of memorization of terms like subclass and superclass, and I don't expect you to retain that from me talking. So if I ever say a word and you don't know what it means, chances are it's in this doc and there is an explanation pre-written. If there's something confusing about that, obviously come ask. I'm happy to clarify things. But since we are going to be going kind of lightning round on this and really cramming the object-oriented programming, we will need, you guys sometimes to just reference this for the meanings of certain terms. I'll explain them as I go, but if there's a meaning of a term that you guys are lost on, again, this doc is your savior and it is going to the chat. You'll also have access to this indefinitely, so no problem with that. Now I'm going to introduce to us the idea of what exactly it is we're doing. You're welcome to get your IDEs fired up and get ready to go. What we're doing today is chess. You all are familiar with the game chess. And the game chess is played on a board, 8x8. And the challenge, the object-oriented part, is that, as we know, every piece has a different set of rules for how it moves. I hear about the audio lag, unfortunately. There's not much I can do. It's just an internet connection thing. So, again, we know that every piece is able to move in certain ways, and those ways are different. So does anybody have a clue as to how we could write a game such that we have all of these different kinds of pieces, which have some properties in common, and some properties which are separate? So for instance, a pawn and a rook will be able to move, but the rook is able to move diagonally, and the pawn is able to move forward. Now somebody says enumerations. Now that is a good idea, maybe. We could do it with enumerations and not have anything object-oriented. That would be a challenge though, because then we'd have to say, if this piece is a certain type, it moves in a certain way, we're gonna have a long chain of if statements. Now other people say inheritance. And inheritance is a very good idea. It's actually inheritance and polymorphism. Those are the words that we'll be focusing on right now. And then somebody says abstract class, and that is very correct. We'll be working with an abstract class, and the terms that are important are polymorphism and inheritance. That's what we'll be working with today. So first off, chess nerds, stop complaining. We're not doing castling, we're not doing automatic checkmating, and we're not promoting pawns. Those are things you don't need to know about. I don't really know about them. I just stumbled upon them while researching for this. But if you're a chess nerd and you care about those sorts of things, then I invite you to write them yourself and then implement them in the game. I will be very impressed if you write them into the game, and if you send them to me or Julia or any of us, and you create a cooler game out of this, then we'd be very pleased with that, and I'm sure that would look really good if you're trying to become a team mentor or something. And then, yeah, that's my recommendation. I don't even know what impersant is. Now, the game design. So we have a board. The board deals with the interactions between pieces. It's always 8x8. We can use an array for this, right? We've seen this before. Now the piece can be abstract, as was suggested by Philman here. Abstract meaning that it has certain properties which we don't know yet, and we'll see that in the code. It's going to be very clear to you after we write more in the code what exactly this piece class and it being abstract will mean. Then we have the side, which we'll do as an enum. If you've seen tutorial 2, you'll be familiar with those. And then the pawn, the king, the queen, all those classes will all inherit from a piece. So the polymorphism is that you can use any of these as piece, and they can all take the form of piece. These are different forms of piece, and the inheritance is that these all inherit from piece. Then there is the game class, which deals with the player's turns and interactions and stuff. So lots of classes today. Abstract classes don't have instances, right? You can instantiate an abstract class anonymously, which means you don't have to create a new class, but we're not touching that today. As far as we're concerned, they do not have instances. However, there are actually like some tricks and there's some black magic you can do to instantiate an abstract class, but again, we won't get into it right now, maybe later. And the key terms here are abstract, which means that it's a class which contains methods, but you don't implement the methods. So you're basically putting a requirement that anything that extends an abstract class must implement these methods. Again, let me reiterate that again with emphasis. If you have an abstract class and you have an abstract method in that class, that is essentially just a requirement to say that if you extend this class, you must implement this method. That's all an abstract method is. Anyways, back to our slides. Then there's super, which lets you access stuff from a superclass. Extends, which is a keyword to have subclasses and superclasses. And override, which means that you can have a method of the same signature as a method in a superclass. It'll be called instead. Here are the important terms. I'm not going to stay on it too long because we're going to see it in the session. And it's in the written doc as well. So you can basically ignore this if you have the written doc open. This is for the people who are just watching the recording and don't have the link on hand. And then they can access the link as well. I recommend that you access the link if you are watching the recording. It's in the My Courses page. Use the link, use the doc. It's very important today. All right, I'll let you guys have a second to screenshot that if you'd like. Just take a look at it. If you have any questions about anything about our plan, now is the time before we can hop right into it. So again, if you have any questions about our plan, now is the time to ask. While I just create our new project. Java version 15, nothing needed, just chess. All right, guys, last call for questions before we start, and then you can obviously ask questions the entire time. You're welcome to just ask in the chat or interrupt on the mic. Yeah. Cool. So no questions about the general plan. Everybody's kind of on the same page that we're creating first, let's say an abstract class for our piece. To create an abstract class, we just do a regular new Java class, as usual. I'm going to call it piece. But now, instead of saying public class piece, we can say here near public class, abstract. Public abstract class piece. Now, having an abstract class gives me certain superpowers, let's say, that pertain to writing this class. First, I can start writing the class as if it was normal, right? I can say, first of all, it needs to store its coordinates, just like the tile in Snake. It just has like a coordinates. So let's call those int x, y. Now, unlike the tiles, also we have to care if our pieces are dead or alive. So we can say private boolean is dead. Right? And these are normal fields. This is just like a normal class. So far, we haven't touched the abstract anything yet at all. This is just working with a regular Java class, nothing special. Hold on, I'm just switching to my not loud keyboard right now because I realized I'm typing on my clickety-clacker and that might be a little bit annoying. Okay, so we've got that. Now, what else do we need? Well, we need to keep track of which side the pieces are on. Anybody got any ideas how we can track the side of our piece, whether it's white or black?
Another Boolean?
Yeah, a Boolean would be a good idea. That would be totally valid. But today, since I want to flex, I'm going to create a new enum for that. And maybe that's because I just want to be able to say like side.black, side.white. I don't want to be thinking about which one is true and which one is false. So I'll just do enum, and I can create this inside my class, actually. I don't need to create a separate file for it. This is just because, logically speaking, the only thing that really cares about this enum is the piece. So I'll just put it inside the piece. Could I zoom in on the code? Yeah, sure, I can zoom in on the code for you. I can make it a bit bigger. Settings. Appearance. Use custom font. Jet, brings monitor. Size. Higher. Or was it, no, this is not the right part. Sorry. I need to do it in my editor. General font. Size 16. That should be better. Okay, now the size is a little bit bigger. Now we've got an enum for our side here, and again, we can create this inside of our class, so that makes our life just a little bit easier. And I can also now put, let's say, a private side. Right. Now we've got our various pieces, parts, and we can even have a constructor, because this is an abstract class. It's just like a normal class, so we can say public piece. Why am I even writing this now? This is nonsense. I'm just going to generate this because we're we're short on time. I'm not going to spend time typing. I'm just going to generate constructor. I want it to take x, y, and side and not is dead, right? And then I'm just going to say by default that is dead is false. Right? And that's going to say that is dead is false until set otherwise. Now I have all those. I have to now add a couple of methods. I actually I have this GUI and stuff pre-written, so I have to have specific names for them, but you can basically do whatever you want. I'm going to say public void kill. So this is how we kill a piece. And we're going to say x is equal to -1. We're just going to use -1 as our placeholder for not on the board. Y is equal to -1. And is dead is equal to true. Now we need some getters. We need our getter for our is dead, so we can say public boolean is dead. And again, this is nothing new. We're just creating a very simple class. And we just return is dead, right? Now, what else do we need? We need to be able to move our piece. We need to be able to change its coordinates. So let's say public void move int x, int y, and we'll say this dot x equals x. It's just a setter for two things. This dot y equals y, right? Very simple. Now, another one we have to write here is to get the side of the piece because we need to know what side it's on. Do we have that? No, let's just get that. Let's just generate getter and setter for side. Now we have get side and set side. Do we have get side or I just click setter? I think I might just click setter. So we'll just get the getter as well. Generate getter. Cool. Okay, so now we have a get side and a set side. We have our is dead. We have our kill. We have our move. But now we also maybe want to be able to resurrect our pieces after they die. So we can have a public void resurrect. Let's just do that. And to resurrect it, it has to go back to a certain coordinate. So let's just do that. So public void resurrect int x, int y. And this is just us playing with the fields. We're demonstrating that in an abstract class, we can still do everything normally. So we can say this dot x equals x, this dot y equals y, and is dead is equal to false. I don't know. I don't know if you can resurrect in chess. I don't think it's ever called. Yeah, I never call it, but yeah, that's just a method. We can delete it if you don't want it. Isn't that promoting? Yeah, promote. Yeah, promoting isn't actually implemented right now, but resurrect would have been used in promote if you guys want to add it yourselves. Now we've added all of the methods we can add that are not abstract. So now we have to add the methods. We'd be able to create a method that moves method for illegal moves. The illegal moves are actually going to be determined in the can move method, which is going to be abstract. We're going to leave this to each piece because remember, what is an illegal move? An illegal move depends on the kind of piece, right? The illegal move for the pawn is not the same as the illegal move for the knight or for any other piece. That's why we have to make it abstract. Now, how do you write all that code so fast? I wrote the code fast because I did a code and then generate, and then that let me generate most of my methods automatically by IntelliJ. Like I didn't have to actually type it out. And that's a good way to increase your speed. Now I'm going to create the abstract method. So I'm going to say public abstract boolean, and then the boolean will return if it's a legal move or not. Can move int x, comma int y. These are the coordinates it's moving to, and boolean for is killing. So because it is an abstract method, I can't actually put these curly brackets here. See, I can't put a body. If I hover over it right now, it's going to say abstract methods cannot have a body. That's because abstract methods are just a requirement that this method is written in every class that extends this. Again, it's nothing to do with this class. This class just says that anybody who extends this class must implement this method. That's what an abstract method means. And another one I'm going to put is public abstract string get symbol. And this is just going to get the symbol that represents the piece. So for example, for a pawn, and again, no body. For a pawn, an example, that would be a pawn emoji. For a king, that would be a king emoji. I just use emojis to represent them in my graphical interface, so that's why I need this method. And again, it differs by every single inheritor of this. So now we have a valid abstract class. But if I try to go into like a main method here, if we create a public static void main, as an example, public static void main string args. Yeah. and I try to create a piece, it's not going to let me. I'm going to say piece, p is equal to new piece. But now it's going to make me implement these abstract methods. It doesn't let me just create a new piece instance. I have to have some kind of thing that declares my abstract methods. How do we handle edge cases like a check? I'll get into those later. We're not doing a fully robust game right now. We're doing a very basic chess game, and we'll see when we actually write the pieces how we're checking for this kind of thing. Okay, so the piece class will check, or like the piece class and its inheritors will check for rules that are related to which piece it is, so where it can move on the board. The board class will check for interactions between pieces, so like if it's going to run into a piece, if there's a piece in the way of a move, the board class will check for that. And then the game class will check for things like checkmate. So we haven't written those classes yet. Let's write some more piece classes. I'm going to write an easy one first, like the rook. And we're going to see how it works. So if I here type rook extends piece, and that's the syntax for making rook a subclass of piece. And I have to click implement methods here. See, I can't just have a rook like this. It has to actually have the same methods as its superclass, which in this case is piece. So every abstract method has to be implemented. And now that I have those abstract methods implemented, and I have to create a constructor matching super, now you can actually have a rook. So did everybody catch that? I have to have every single method that is abstract in piece has to be overridden in rook. That's the rule about abstract classes. Now, I'm just going to copy paste get symbol because I don't want to find the emoji again, and I have it pre-written on the other side here. So I'm just going to paste in my emoji string here, which is the rook. And I'm going to get the rule for a can move. So can somebody tell me what the rule is for a rook in chess? Like, how does a rook move along the board? Well, a rook moves in straight lines, yeah. So when we say a straight line, a really easy way that we can check for this condition is, and again, it doesn't depend. It doesn't matter if it's killing something or not. Like whether the move is going to kill something doesn't depend on how it's going to move. I think only the pawn cares if it's killing something. So here I can just simply return a simple Boolean condition on the coordinates. I can say that this dot x is equal to x. So either the x coordinate doesn't change, or this dot y is equal to y. So either the x coordinate doesn't change or the y coordinate doesn't change, right? Does that make sense? It's a very simple class. The rook was a very easy extension of the piece class. Now I can do this a couple more times. Let's just do another easy one. So the rook is easy. I'm pretty sure that the bishop is also going to be similarly easy. So let's do the bishop. Extends piece again. If there's any questions, I'm happy to answer them. These ones are a bit of a slog to write anyway, so I'm happy to discuss any of your questions while I write them. So I have to implement the methods, right? So I have to override every method that's abstract. I have to create a constructor, just like super, which is also automatically done. This just says it calls the constructor of piece. It actually shows me if I hover over super that it's calling the piece constructor right here. Now, the bishop here can move in diagonals, right? So what I can say is that the difference in x, so int diff, again, this is just really easy stuff, so I'm going to go super fast. You've seen this in previous tutorials and everything. You know how to work with ints now. So this dot x minus x, int diff y is equal to this dot y minus y. Very easy. And then return the absolute value of x is equal to the absolute value of y. So I can say math.abs of diff x is equal to the math.abs of diff y. Now this is the difference between importing and extending. So you can see, well, I don't even have the import statement here, but I would be importing Java util math here, right? And I'm importing math, but my class bishop has nothing to do with math, right? It has everything to do with piece, but it has nothing to do with math. So this here is an import, and this here is an extend. Does that kind of make it more obvious to you guys how extend and import are different? Here I'm using, what are x and y, like your coordinates on the board? Yeah, they are. And again, x and y, see I say this dot x and this dot y, but I don't actually have a field here, this dot x and this dot y. So how am I accessing it? What field is this? It's purple and it's this. So it must be a field, but where do I define this field?
In pieces?
Yeah, I define this field in the piece class. So when I extend piece, I define the field. Now can somebody tell me, can I access the isDead field from bishop? Is the field of piece called isDead accessible from bishop? This one. Can I get this from bishop? No, I can't. That's because it's private. So even when I extend a class, I can't access the private fields. That's what no access modifier, public, or protected are for. So now I've got rook, I've got bishop. What's another relatively simple piece? Maybe the king. The king is a simple piece, or is it? Let's see. So Java class king. Oh, and I forgot to do the symbol for the bishop. Let's just get that as well. So I'm just pasting these in from my other lines, and if you guys would like to follow along, I can just send you all the get symbols near the end. So bishop, now king. King is a tiny bit different because I think we want to do something special when the king dies, right? But first we have to extend the piece, just like before. And we have to implement the methods, and we have to then, I'm just pushing Alt-Enter, by the way, to get that pop-up. And we have to create a constructor. Now our move is going to be very simple. We're just going to say that we care about the fact that it's within one block of where we are. So we'll just return. In fact, you know what? I'm just going to paste it in because it's very simple. We just return the difference between the current position and the new one. How do you do the implement methods on IntelliJ? You can right-click on your class when it's red, show context actions, and then it'll have an option to implement methods. It'll be automatic for you. So you just right-click on your class, show context actions, and implement methods. I'll show you again when we go to the next class. So this one just makes sure it's within one coordinate, and the get symbol will return the crown. But now, I have one question for you guys. I want to do something about kill. Is there anything I can do? Can I override a method that wasn't abstract? Can I make kill do something different in this king class? Now, I don't want to do anything that special. I think I'm just going to do a print line. But let's say I want the kill class to do the same thing as the kill class from piece, but I also want it to do something to inform me that the king died. So how do you think I could do that? What's a good strategy to get the king's kill method to do something that's slightly different? Well, actually, the way we accomplish this is we can also override methods that are non-abstract. We can override whatever method we want. You can see in my suggestions, it's actually suggesting me lots of different overrides. I'm just going to override kill. And now it's automatically filled it in that I'm going to override the kill method. It's going to put the @override. It's going to have the same signature as the piece one. So I can't say, for example, kill and then take an int as an input, int I. That's going to give me a highlight since I'm not overriding it properly, right? Since I need to override it, I have to have the exact same inputs, outputs, and name and everything. So that's why the override is important. So super is an override keyword. Super is a keyword which says that it calls the method kill in piece. So I'm saying that here I'm saying do whatever kill does in the piece class. And then here, do whatever I want. So here I'm going to system.out.println. The king has died. Long live the king. Something like that, right? Whatever you want to put. But I'm going to print out that when the king dies. And that shows how I can override the kill method of the piece. And this is also a useful part of polymorphism. If I have an array of piece and I say, for every piece in the array, piece.kill, all of them will print nothing. But if the king gets killed, it'll print out this. And that's something like you'd see on a quiz. On a quiz, you might have a question where you have, let's say, an array of pieces. And it says that for every piece in the array, you kill them. And it's going to say, what does this print out? And then it'll give you, let's say, the bishop class, the rook class, and the king class. You have to identify that since this method is overridden in king, it's going to print out this string if there's a king in your array, if that makes sense to you. And again, you guys are welcome to ask any questions just as I go, because I'm going to be writing out this lot of classes that are relatively simple here. And then we'll get to the hard classes closer to the end of it. So I'll create a new class called queen now. And queen will take some of the movement properties of both the rook and of the bishop. So I'm just going to reuse some code from there. And again, when I extend a class, I type extends piece. It gives me this red underline. I can right click, I can show context actions. And then I have two options. I can either make queen abstract so it's valid, or I can implement the methods. Usually you want to implement methods. That's going to give me this pop-up. It tells me which methods do I want to implement. I'm going to take those two, copy them over. Now it's still red. It wants to have a constructor. There's no constructor right now. So I'm just going to create a constructor as well. And now it's my job to fill in these methods that are left abstract, that are different for every piece. And for me, I'm going to put the the queen's crown in here for the symbol. And I am going to put the rules from the other classes into can move. But before I do, can anybody tell me what the heck this is? I don't think you guys have seen the syntax before, have you? This weird syntax with the question mark in it and stuff.
Is it just a if, else if, but condensed?
Yeah, it's like an if else if condensed. What it's saying is here we've got a Boolean condition. So this condition either is going to be true or false, right? We can all see how this statement will be either true or false. Then the question mark is saying that if this statement is true, we're going to put the first the first option before the colon. And if this option is false, we're going to take the second option. It's a way to create one of these declarations in one line rather than making like 5 lines. It's just a very shortened if-else block. Now, Philmon said, can you repeat what he said about overriding the methods? Sure. So when I was saying in King, I want to make the kill print something out when he dies. So what it's going to do is it's going to call the kill method of its superclass. So it's going to call the kill method of peace by typing super.kill. Super.kill is just a keyword that says it's going to call the kill method on its superclass. You can do that if you're overriding a non-abstract method. Then after I do the super.kill, I can just put whatever I want, and here I print it out. That's what I mean by overriding a method. And it has to have the same inputs, the same return type, and the same name as the method I'm overriding. All right, so on to the queen's movement. We're just going to take it from the rook and from the king and from the bishop. So I'm just going to copy paste this in from my solution. I'm not going to go into the math. Again, this is just simple int math. Like it's very clear. If you guys have questions about it, you're welcome to ask at the end, but it's very simple. It's not to do with what we're learning here, so I'm not going to go into it in detail. We've learned this in previous lessons. If you want more on this, tutorial 1, tutorial 2. This stuff hopefully is covered. Now we can go into the knight, and the knight is another simple class. I'm just going to speed run the knight class because we've kind of gone over most of this content. So knight extends peace, as we know. We will do all of the extension stuff, implement methods, right, blah, 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 blah. And I'm just going to take the whole thing and put it in from my solution. Being very lazy with knight, but it's the same as all the other classes. There's nothing new to learn in knight, so I'm just going to skip that. And I'm going to speed it up so we can get to the interesting parts. So now we've covered rook, queen, we've covered pawn, or we've covered knight and we've covered king. We haven't covered pawn. That's the hardest piece. So let's get into pawn. Now pawn has a lot of lessons in store for us. So first we're going to extend peace, and we are going to see a lot here. So the pawn has a couple of interesting properties that make it different from other pieces. The first property is that a pawn has different behavior depending on whether or not it's moved. So the pawn has a different rule for can move for if it moved before and if it didn't move, right? Does anybody have any idea how we can track whether our pawn has moved or not?
Another Boolean has moved.
Yeah, we can create another Boolean. And yeah, when we extend an abstract class, that doesn't stop us from creating fields. So I can still create another field in this class that is private Boolean has moved, right? Very simple, but it kind of feels weird sometimes when you see it like that. Because, you know, this is an extension of peace, but we can basically do a full-fledged class in here. And now we can say has moved is true, or has moved is false in our constructor. So when we create a new one, has moved is false. So our constructor can have stuff other than the super call, right? This is just a normal class. We just also have to put in the super. This is required when you override the class, or when you extend the class. And now we're going to have to override move, right? Because remember how when we move it, we have to update our Boolean. Does anybody have an idea how we can update has moved whenever the piece moves? So how can we update this whenever the piece moves? Now we don't want to have to say if the piece is instance of pawn, then you update the Boolean, right? We could do it like that, right? We could in our board class say, if the piece that we're moving is an instance of pawn, then has moved equals true, right? That is possible, and that's a solution that some students would probably come up with if they don't learn this well. But we can also move that check into a overriding method. It's more clean code because now we can treat all the pieces the same. We can just type piece.move, and each piece takes care of that for us. It's a beautiful thing about object-oriented programming and polymorphism, that move has the same name and the same inputs. And here I'm just manually typing it. I'm not even making the override like that. And now it's overridden. So we can type super.move x comma y, and then we can simply say has moved equals true. Now this is the very beautiful part about polymorphism. This is the part we love about object-oriented programming. Because if we have an array of piece, we don't have to check if it's an instance of pawn. I remember on Piazza I saw a question that said, we have an enhanced for loop and an array. So how are we going to, get through, and how are we going to call these methods on each instance? Do we use instance of? I say no, we don't use instance of. We can use overrides like this and inheritance, so that we have methods that have the same signature but change their behavior depending on which piece is there. Again, this is the really nice part about OOP. So get symbol is simple. We'll just paste that right in. And can move is a little bit more complicated, but it's long. We don't have too much time, so I'm just going to paste in the solution. I'm going to explain it quickly. Here, this line, what it does is it checks the direction. All right, the direction is, for me, the direction is negative if it's white, it's positive if it's black. It has a required difference x, so it's saying that if killing must move over by 1 on the x coordinate, right, because it has to go on diagonals if it's killing. And if it's not killing, it has to move by 0. So it's saying if it's killing, it has to move 1 diagonal. If it's not killing, it has to move 0 diagonals. And if it hasn't moved, then the acceptable difference in y is multiplied by 2. So hopefully that's relatively simple. This is saying is that if the difference in x is not meeting the requirement, it returns false. And then it's saying that the acceptable difference y is greater than 0, blah, blah, blah. It's just checking that if the height that it's moving is correct and in the correct direction. Right? So this is can move. It's also a relatively simple override from piece, and it just has a few more lines. If there's any questions about it, they're welcome now or at the end. But again, this method is relatively simple. And now that we've finished our pieces, we can actually look at something pretty cool. If we right-click on our source folder and we click diagrams and show diagram, Java classes, we'll wait for it to load for a second. And we can ignore this package of garbage. We don't want those here. We can just, these are all the packages we imported. We can just pretend those are not there. We just care about this top part. This part's what matters. So here we can see that the bishop, the knight, the king, the rook, and the queen and the pawn all extend piece. And if I show methods, then I can actually show you what methods are overridden in each class. So here we can see that pawn overrides move and get move, and it actually shows you which ones override. So here I can say that those methods are overriding those and blah, blah, blah. And here I can show my fields. And this is what's called a class diagram. You've probably seen these in lectures before. And here we can see which classes bring what. So we can see that all pieces will have these methods available to them. Now I'm going to give you a question of the format, kind of like a quiz question. Oh yeah, sure. Where did I get the diagram? You have to have IntelliJ Ultimate Edition. And you can get Ultimate Edition for free if you look at the software installation guides. You have to sign in with your Miguel ID. Anyways, you can go back to the software installations if you need to know about how to get Ultimate Edition. You right-click on Source, you click Diagrams, Show Diagram, and then Java Classes, and it's going to bring you this. And here we can see that each of these classes, again, they inherit from piece. You have all of these methods available to you in piece. Since all of these methods override, you have them available for all the pieces. But if I had a method unique to a piece, then I could only call it from that method. You have to cast. Can I get the diagram in Eclipse? And is that a UML diagram? This is a UML diagram, and I don't know how to get a diagram in Eclipse. I'm sorry, I only know how to do it in IntelliJ. I'm sure you could in Eclipse, but I don't know of the way to do it. So yeah, that is the diagram, and that's just kind of a cool looking thing we can do. And if we create now our board class, we can go a little bit further. So new Java class board. Now the board, for once, doesn't actually extend piece. The board is just a class that deals with the game. So what do we need? Well, let's say we've got a private piece array, double array, and same as the tic-tac-toe, same as snake, board. All right. And now we just say, we can have a constructor, right? Then we have move, we have can move. We have a couple important methods here that are long. Let's say our first method we want to write is reset game. So how about public void reset game? And then we're going to reset it for each side. So we're going to have to say boolean is black. So we're going to reset it for depending on which side of the game it is. And here we're just setting our values. First, I'm going to copy paste a bit of starter code here, like this. So we're saying that here we're just determining our properties. So up here we are determining the rows, index, and the color of the pieces. Easy peasy. There's just something I didn't feel like writing, typing out manually again. But now, here's the spicy part. You see how board is a double array of pieces, right? The board is an array of the piece class. Well, to fill an array of the piece class, how are we going to add our various pieces to it? Can I just say like board 0 and king row is going to be new piece? Is that valid? Well, I have to fill in all this stuff. So what can I do here? Is there some sort of Java object-oriented programming principle that's going to help me here? So if we think back to our diagram, we know that everything we've created here is an instance of piece. That means anything here with the blue arrow pointing to piece can be used in place of a piece. If on the left side, I guess since the camera is mirrored, on the left side of my equals sign, I write piece, I can put king, queen, knight, pawn, rook, anything I want on the right side that is an instance of piece. So instead of being forced to put new piece, I can put new and then every other kind of piece. And what do I mean by kinds of piece? I mean anything with the blue arrow pointing to piece. So here, 0 king row is going to be a new rook. And let's just say it's going to be at index 0, and it's going to be on the king row, and it's going to be on the side. Now, I can also do the same thing for, I'm not typecasting, I don't have to cast anything. I'm just saying that whatever is going to be in this, whatever piece needs to go here will be a rook. And I don't actually have to cast anything. I'm just putting the piece in that slot. I'm saying that the piece in this slot will be a new rook. I can say piece P is equal to new rook. And that's a valid piece of syntax because a rook is a piece. So I can fill an array of piece with rooks, knights, queens, kings, whatever. Now I'm just going to get the rest of it because I don't feel like typing such a repetitive thing. This is just filling the row with the kings in it. It's just creating the layout of the chessboard, right? I'm just saying new and then the various types of pieces for every slot in the king row. Now to fill in the knights, or fill in the soldiers, the pawns, I don't want to have to type in every single one separately, so I'm going to use a for loop. And I'm going to put constructors in the for loop. I'm going to say int I equals 0, I is less than board at soldier row dot length, and I put O instead of I there. Let me fix that. I is less than board at soldier row dot length, and I plus plus. Now I can fill that up with pawns. So I can say board at I and soldier row is equal to new pawn I soldier row side. Right? Does this method all make sense to you guys? I fill this board with various kind of stuff. It might look sacrilegious to say that the same array is taking in things of type bishop, things of type king, things of type knight, things of type queen, type rook, but it makes sense to you guys why that works, right? My array can contain whatever the hell I want because it contains specifically pieces. If I try to put something that's not a piece in my array, if I say board at 0, 0, 0 is equal to new string, or if I just put a string, like hello, that doesn't work, right? Because it specifies that it needs to be a piece. That is the #1 rule of Java object-oriented programming. The rule is, the golden rule. We say less specific on the left, more specific on the right. Does that make sense to everybody? So left gets the more specific bit, or the less specific bit, right? So piece is less specific than rook. We know that a rook is a piece, but a piece could be a number of things. A piece could be any of these, but a rook is only a rook. We have to put the less specific thing on the left. That is the rule. If I try to say rook r is equal to new piece, that will not work. It's simply invalid because piece is, well, it's not just because it's abstract, but also because you can't put something less specific on the right. It has to be the more specific thing on the right, right? That is a rule you need to remember. So make sure that is clear to you guys. And are there any questions about this method? All right. If you have a question about the method, it's your time to ask. And otherwise, I will carry on to another method. And I'm going to ask you guys for some input on how I could write this. So I'm going to say public king get king. And I'm going to take a side. So I'm going to say side. Side. Right? Now, how do I get the king out of my array? What do I do? How can I get the king off my board? I know my board is an array of piece. How do I get the king out of it?
Set his position to null.
Well, I don't know the king, right? I don't track anything except for this array, right? I track a double array of pieces. That's all I have access to. The only field I can access is the board. And the board is an array of piece. Is there something I can do to find the king on this board?
Well, access the position field of the king. King.x.
Yes, but I don't have access to the king, right? I can't say king.x because I don't have a king. I'm trying to get that. It's a good suggestion, but it depends on what we're tracking. If we're tracking the king as one of our fields, then yes, we can say king.x, king.y. But since we're only tracking our board, we have to kind of find our king in the board. So I'll give you guys a bit of a starting hint. We'll say for piece, and then we'll say array in the board, and then we'll say for piece p in the array. Now, this might narrow down our possibilities, right? We're going to look in our board and we're going to look for our king here. But how do I check if a given piece is the king of the correct side? Philmont says instance of. Do you want to elaborate on that? You're welcome to come on the mic or... Yeah,
sure. So you check within the array the elements that are knight by asking specific element is instance of, for example, knight or king.
Sure. And while you're at it, I see Harsh here suggests get class. Do you have any idea how get class would be different? Like, what would be the difference between using get class and instance of here? Okay, well, get class and instance of kind of do the same thing, but I find instance of to be a bit shorter because if you say get class, it says you have to do get class dot equals p dot get class, and it's not null safe. So I generally say instance of is a better idea. Although they do a similar thing, get class is just more complicated. You have to write more lines of code. They do check the same thing. So I would recommend instance of, but get class could work too. It's just more lines to write with get class, and it can be annoying with null. What does line 31 do? Well, this piece dot side is just an enum that says black or white, so we get the right king. Because, like, obviously the players would want to be able to find the king of their opponent, so that's why you need to specify the side. Now we can say if p instance of king, right? But I can't return p, right? Let's say return p, because p is a piece. So does anybody have any idea how I could solve that problem? How could I return a king when what I have is a piece?
Typecast it?
Yeah, I could cast it. But if I'm going to cast it, why couldn't I just say, why couldn't I put that here? Why couldn't I just cast it without checking instance of? Why can't I just say this?
Because that's casting for anything, not necessarily king.
Exactly. Here I'm casting whatever piece is there. I don't care if it's a king or not. I'm just casting whatever is in that slot at the time. So I might cast a rook to a king, and that can cause some serious problems. So for that reason, I have to cast it to king. But now I also take my side as a parameter. So how could I check that the side is correct? Well, I could say and p dot get side is going to be equal to side. But now, can somebody tell me, why do I not need to cast here? Why am I casting in this part, but not casting in this part?
every piece has a side. It's not necessarily to like.
Yeah,
choose a
exactly.
specific one.
That's because every piece has that method. If I had a method that only the king had, I would have to cast, right? Or if here there's something that requires the king, I have to cast it. But if it doesn't require it to be a king, if it can be any piece, I can just do it on piece. If we look again at our diagram, our piece contains the getSide method, right? But it's going to call getSide as it's overridden by any other class. So we have this method. We have our getKing. Now I'm going to have another method, getPieces, which I will paste in from my other one. This is required for the GUI. Uses array lists, so it's a little bit over and out, but it basically just gets all the pieces on the board out for a given side. And then again, it's not crucial, you need to understand that. I have a method called get, which just returns a piece at a given coordinate. And it just gets whatever piece is there. GetKing, and I'll have a toString method which just draws out our board. Again, this one is from before this tutorial, so if you guys are curious about it, this is content from tutorial 2, so I won't really go into it, but if you have any questions about it at the end, I'd be happy to answer. We're going to go into the important parts. So in my reset game method, I'd reset by side, so I'm now going to overload that method. Now, what does it mean to overload a method? How can I overload reset game? What does that mean?
Same name, different argument.
Yeah, overloading means I have another method, same name, different arguments. I'm going to say public void reset game, and this is going to reset the game for both sides. So this is overloaded. It's not overridden, it's overloaded. I'm going to say board equals new piece 8x8. And I'm going to say that reset game true, and you don't have to call the overloaded methods from an overloaded one, but here I am, and I can call those reset games. So why is this not recursive? Why is this method not going back into itself when I type reset game? Although the name is the same, what's actually happening is that when I call reset game, it's going to call this other version of reset game with the Boolean argument. So if I get rid of this true, you see here we have a loop. It actually tells me this is going to loop. It's going to just go back into itself recursively over and over and over again. It's going to go reset game, and then it's going to call itself. It's going to do this infinitely. But since I have this argument here, it's calling the overloaded method here, public void reset game, and it's using this one instead. So there's a difference between these two methods, and you can call one by adding the arguments or not adding the arguments. Now I can't overload it with a different Boolean. If I say Boolean something else, that's no longer overloaded, because even though the name of the Boolean is different, it's still takes a Boolean as input, so it's not an overload. Does that clear to everybody how overloading works? And the difference between overload and override? Again, I will be taking overload equals multiple definitions. That's right. Overload is just you have multiple methods with different arguments, and override is changing the method. You're exactly correct. All right. And if there's any questions about it, again, happy to answer either now or in office hours on Piazza, wherever you want to ask, happy to answer. Now I'm going to create a method for moving a piece on the game. How do you change the method? Can you explain that, Diane?
Yeah, it's just regarding like the comment that was given in the chat. They said that override is like changed it, and I thought that they meant the method when they talked about override.
Sure, overriding is kind of changing with the method, right? So here I have, let's say, piece, and in piece I have the method move, and the move just sets x and y, right?
Right. Yeah.
And then when I override that in pawn, I'm changing what the method does. I'm saying not only do you have to move like a piece, you also have to update the hasMove field. That's overriding. So I'm adding extra functionality to that method.
All right.
And
Okay,
in
makes
fact,
sense.
yeah, if I don't want to update the coordinates, I can make it a completely different method. It's still overriding if I don't put super. But yeah, you can just make the method do something else. Then
Okay.
Yeah. All right. Now.
And it has exactly the same header?
Yes. To override, it must have the exact same header, the exact same method signature. In fact, the header doesn't have to be identical. You can name the variables whatever you want, so there can be differences in the header, but there may not be a difference in the signature. And if you want a really good definition of that, it's in our doc. There we define signature explicitly. That's just kind of the inputs and outputs of the method and the name. but stripped of anything that's sort of customized. So, yeah.
All right,
Okay.
thanks.
For sure. All right, now back in our board class, we got to kind of skedaddle to get the move method done. So it's taking the x and y we're starting at and trying to move that piece to a different x and y coordinate. So we're saying if can move, which we're about to write afterwards, x comma y comma dest x comma dest y. So it's going to say if we can move the piece, checking our rules, which we will do there, we'll do that. Else we're going to throw an illegal argument exception. Throw new illegal argument exception. Illegal move. Right, that's how exceptions work. If you fail a certain condition, you can throw an exception. Any questions about that, I'm happy to answer as well. Now we can simply check that if the place on the board that we're moving to is not null, we have to kill it, right? So if board dest x and dest y is not null, and can anybody tell me why I'm checking if it's not null? So why do I need this check? Well, I need this null check because a piece can be null. If I'm writing this method, whatever is in this slot of piece may be a null. So that's why I have to check if it's not null before I kill it. Then I can say that I'm going to move from board xy dot move to dest x, dest y. Then I'm just going to say that board at dest x, dest y. I'm just moving this piece. I'm moving this piece from one place of the board to the other. So I'm going to copy it over to the new position. Board xy. And now I'm going to say board xy is null. So I just move this piece over and I put its old position to empty. Equals null. Right? And the reason that I check this, it's not null, that's so that I can make sure that I don't get a null pointer exception. Now I'm going to go very fast on can move, public boolean can move, and then I'll supply you guys with the game class so that you can actually play the chess game. But first we might go a few minutes overtime on this can move method because it's a bit spicy, but it is going to be very reminiscent of quiz questions, and it is going to be quite heavy on object-oriented programming. So I recommend that you do enjoy it. It's only going to take maybe a few minutes after 2. So in our can move method, we will first have to identify what piece we're moving. So we'll say piece to move is equal to board at x, y. Right? Then we're going to try to figure out if it's going to kill something. So we say killing is false. And we're just doing this check here. And we're saying if to move is not null, we're going to return false. Or if to move is null, we're going to return false. Because if there's no piece where we're trying to move from, we return false. And we have a couple more of these conditions. If it's a kill, so if the board at our x and y coordinate is not null, then killing is true. And we're going to fail, it cannot move, if the piece is on the same side. So if you try to kill something on the same side, well, yeah, don't. And then we're going to just check the can move method of the piece. Because remember, we wrote a can move method in piece. So we're going to say if exclamation mark to move dot can move. So if the piece that we're moving can't move to dest x, dest y, and we tell it if it's killing or not, then we can return false. So if the piece can't move there, we can return false. Again, so here we're calling to move dot can move. It's a method in piece, right? But in piece, that's an abstract method. Can somebody tell me why we can call this method on an abstract class, even though that method is abstract, right? Because we're saying here it's a piece to move, but here we're calling a method on an abstract class, and that method that we're calling is abstract. Can somebody tell me why we can call an abstract method in this situation? Yeah, it's abstract method that we're calling, but here we're calling it just like that. So what's going on here? Why can I do that? Why can I call this can move method is a public abstract boolean? Because every piece moves differently. because all subclasses have that method. Exactly, because since it's an abstract method, I can call it on a piece, because we know that whatever is in this array is not going to be piece. It's going to be a pawn, a bishop, a knight, a queen, a rook. These all have the move method, because abstract means that there's a requirement that that method is written in the subclasses. So here we're not really calling the abstract method. We're calling the method in whatever piece, and it's just saying that piece is saying we're going to call a method of this name, and then it's the job of rook, bishop, king, queen, knight, and pawn to actually make that happen. All right. Now I'm going to do another bit of a spicy check. I'm going to say if. Now, how are we going to do it that a knight can hop, right? We know that, so we must check collisions unless it's a knight. So how can we do this? How can we check if the piece is going to collide with a different piece on the way if that only applies to knights? What can we do about this? How can we make some code run only if the piece is a knight?
Can we do again instance of knight?
Yeah, we can do an instance of check. So we can say if exclamation mark to move instance of knight. So if it's not a knight, we have to check collisions. Now, how do we check collisions? Well, that's actually a lot of math, so I'm going to copy paste it from my solutions. Again, we're running out of time, and it's a very long method. So I will paste it, but I will also maybe go into it in a Friday session to explain how I'm doing it. It's nothing to do with object-oriented programming. It's just math. You can see a lot of math calls. I'm calculating what is the path between the two coordinates, and I'm checking if there's a piece in that path. Right? That's all that method is doing. And now I'm going to return true if all those conditions check. So I'm going to return true. Right? Now this, again, is complicated. It's long. That's math that calculates the shortest path between the two coordinates, or like the path that the piece will take between the two coordinates. It has nothing to do with our objects. It's just calculating if the move is diagonal or linear, and then it's making approximations based on that as to what the rule should be enforced. Now, y dest x cannot resemble symbol dot x. Oh, that's why. Y comma dest x. All right, now we have valid classes for all these, and right at the end of the day, right at the right time, I'm going to supply you guys with a couple of classes that are going to help you to play the game. So the first class I'll supply you is game, and the second one is game app, and these will let you play the actual game. So if you run gameapp.java, you will see that the game will be playable. I just sent those on Zoom to everyone, and I'll also send the link will be available to those on my courses for those of you who aren't there. And I'll just copy those into my source folder here as well. I'll show you how to do it. So I'll open in Explorer. Then I'm just going to drag my game files in. So where's my Explorer? It's right here. I'm going to drag my files in, game and gameapp.java, right into here. I'm just going to copy those and I'll put them in source. And now I should have them appear here. And they're going to have a complaint that it's in the package chest. We can just get rid of that because I didn't put a package this time. And this one too. And now if I run game app, what I can do is I can actually show you the rules. And now it's also time for your questions. If you have questions, it's your time to ask now. Oh, what is it not like? Oh, did I forget the constructor? I forgot the constructor in board. Silly me. Let me fix that. Public board. What does it do? It resets game. That's all it needs to do. The board constructor just needs to make the board work. Sorry about that. I forgot the constructor. Very silly mistake. But now if I run game app, here we have our actual chess game. And if I try to move from 1-1, it'll show me the valid moves, and I can move that to, let's say, 1-3. Can I? Dest x 1, dest y, no, y 1, 2. Play. What's wrong? What's wrong with you? Anyways, I digest. If there's any questions, anything like that, I'm happy to answer. My GUI looks like it's bugging a little bit right now. So what I can do is I can just show you that on my other system with everything open. Here it is. And if I run the chess game, on here, you'll see it running. There might be some slight error in some of the code I wrote, but here if I demonstrate it, I'll full screen that maybe. y'all will see exactly what it's doing. And again, I'm taking questions now if you want them. So my origin x will be 1, 1, 1. I will peek at where I'm going. So I'll say peek. It tells me the valid moves. And I can move to 1, 3. Make that play. Oh, that's because I'm on the wrong side. That's why. Sidetracking. Silly me. White goes first. So if I do 6, 1, 2, 1, 6 to 1, 4. Yeah. So it just depends on which piece I'm playing. Anyways, yeah. Questions, welcome to be asked now.
I have a question.
Sure, what's up?
It's mostly about the moves you're making with like the bishop and like queen and stuff. Like they're all going in diagonal. Even the knight is going in like in this L shape. And I'm just wondering, how do you code this? Like math? What kind of math do you use?
Oh, for sure. It's very, very simple. I'll show you the knight, for example. So for an L-shaped move, I'm just saying that, you know, the L-shaped is going to be like 2 up and then 1 over, or 1 over and 2 up, right?
Right.
Well, when we work with ints, we don't have decimals, right? So what we can say is that it's going to have to sum to 3. As long as one of them is greater than 0, there's no negatives. We know that to have 1 and 2, it just needs to sum to 3. So all I do is I take the absolute value of the delta x and the delta y, which is the difference between the current x and the current y. And then I check if their sum is equal to 3 and that they're both positive. And then that way it guarantees that it's an L-shaped move. It's like, I guess, a math trick for it. I didn't want to take the time to explain these in detail during the thing because it's all about the object-oriented programming and it's a big cram to get chess done in an hour. But yeah, the math for these is all really simple. And you have access to the source code here, so hopefully it's relatively self-explanatory. For the queen, I just copy-pasted the checks out of other pieces and put them all together.
Okay.
And for for the rook, it's very easy. I just check that the one of the lines is on the same line, as long as one of the coordinates doesn't change. For the bishop, where's that? Somewhere here. It's on the side. For bishop, I just check that the difference between x and the difference between y are equal to each other. So like when it's diagonal, it's gonna have the slope of 1. So yeah, again, they're relatively simple stuff.
Okay. And also for like side, the variable, is that just like the color, like either it's like white or black, or is it something else?
The side determines the color, and then if you actually look in the game class, which we didn't have time to write, but the side also determines who played last. So the reason I couldn't move there a second ago was because I was trying to move a black piece when it's white's turn. So here, if I try to move from 1, 1, and I peek, it says it's a valid move to go to here, and I try to move that to 1, 3. I can't do it because I'm on the wrong side. But if I try to move from 6, 1 to 6, 4, something like that, I can move that because it's a white piece. Now I have to move a black piece. Anyways, that's just chess rules.
And your x and y, like the one is like the other side of the board, and like your white knight is like 8.
So this is 0 up here, and this is 7 at the bottom, and then it goes 0 and then 7. It's just the way that Java draws. Like if you draw an array with the Java graphics library, like I'm doing here, it draws from top to bottom. So that's why it's like that. And here, if I try to run the horsey tells me it moves as well. And yeah, that's just the chess game.
Love the name, by the way.
Oh,
nice,
sure.
Nice play.
All right, and if there's any further questions, I'm happy to answer. Otherwise, I'll be wrapping up in due time. All right. Well, then I will assume no further questions. I know that was a really fast session, guys. It was like a super fast lightning review of object-oriented programming. And I'll try to make it more, maybe more detailed next time if this one was confusing to people. And again, questions, Piazza, office hours, it's all open to you. The purpose of this being so fast and so dense was to give you guys this really, really strong foundation in OOP and like a trial by fire, basically. Every single concept I tried to cover in this one hour session. But if you could get through this entire session and understand everything I talked about, then you are set for the assignment. And that is pretty certain. So yeah, if you understood everything I did here, the assignment should be absolutely no trouble. And one final bonus piece for you guys is if I go diagrams, show diagram, Java classes, and then I put, where is it? Yeah. Yeah. Now I can also see what does what. So I can see that the game app contains exactly one game. Yeah, the game app contains exactly one game, and it contains exactly one chess engine, which contains a board, and you can see what contains what. And this is a very detailed UML diagram of this whole game. If you ever wondered, like a proper UML diagram, you'll see these in later courses, ECSE 223, don't know what the comp equivalent is. This is our UML diagram, and it shows me exactly how the structure of this whole application looks. And in IntelliJ, you just right-click on the source folder, you click the diagrams, and then you click Show Diagram. All right, thank you guys so much for coming, and hopefully you enjoyed the session. Thank you, and bye-bye.